Demystifying emergency lighting standards. In the emergency warning world, there's a lot of confusion about emergency warning light and other lighting standards. SAE stands for Society of Automotive Engineers. SAE is comprised of to thermal performance, to color specification. Is that red brake light really red or more pinkish? While SAE is not law in most areas, it is a best practices standard that the entire automotive world pays attention to. Comparing SAE numbers usually gives a good level playing field comparison between lights. SAE publishes thousands of standards, each one numbered. Within each standard, there are usually classes that specify performance. When a vendor says SAE compliant on their website or literature, they should also specify the standard number and the class. Without it, the term SAE compliant is meaningless. SAE J845, minimum standards for omnidirectional emergency warning lights. For the sake of this article, we will focus on amber beacons, rooftop lights. This is what's known as an omnidirectional beacon, meaning they shine light in a 360-degree pattern. The standard for light intensity for this beacon is SAE J845. Within J845, there are three classes: Class 1, brightest; Class 2 and Class 3, dimmest. Light intensity is measured in candela seconds minute. Class 1, clearing traffic, 18,000 candela. Class 2, blocking traffic, 4,500 candela. And Class 3, identification only, 800. As you can see, there's a very dramatic difference between Class 1 and 2. While SAE labels Class 2 as the standard for blocking traffic, your vehicle is stopped and blocking a lane. Keep in mind that SAE is a minimum standard.
We always recommend Class 1 unless special circumstances exist, such as the vehicle is in a warehouse or a dark mine, etc., and Class 1 might be too obnoxious. For roadway applications, though, Class 1 is the class to go with if you want the brightest light. SAE J845 also controls the color. You may have noticed that some amber, yellowish lights are more of a pale yellow, and some are a richer yellow color. The pale yellow ones will likely still meet the J845 specification for color, but just barely. There are some beacons who use a lighter shade of yellow to get more intensity out of the light. It's easier to make the light bright if you shine through a pale yellow lens rather than a deep yellow lens. They run just barely inside the SAE specification. Others, like the federal signal lights, tend to have a richer yellow-amber color that is in the middle of the SAE specification. Directional lights. You may also see reference to J845 for directional lights. This doesn't mean lights for traffic flow control, but rather a light that puts out light in a specific direction, as opposed to an omnidirectional 360-degree light like a beacon. While originally designed as an omnidirectional standard, J845 has been adopted to a standard that covers a directional light as well. The light must meet certain intensity specifications out to plus or minus 40 degrees off axis and plus or minus 5 degrees vertically. Note that the peak intensity requirement for J845 directional is lower than J595. SAE J595 was originally the directional light standard and is still used as that. It's a bit different from J845 in that J595 requires a higher intensity than 845, but only to plus or minus 20 degrees wide, but requires plus or minus 10 degrees up and down. This is why you will sometimes see a surface-mounted directional light meet J845, but not meet J595. In that case, it tells you that the light has good off-axis, but isn't necessarily super bright. If it meets both standards, then it is bright and has good off-axis as well as good up-down light. Ideally, your lights should meet Class 1 for both standards. Also, check the color for each compliance claim. Often a light will meet Class 1 in red and amber, but not in blue. Blue LEDs emit about half the light energy of red, so it's tougher to make blue compliant to a standard that requires high intensity.
California Title 13. Alongside SAE statements, you may have seen reference to California Title 13. Title 13 is pretty much the toughest spec for light intensity. The important thing to note when manufacturers say they are Title 13 compliant is that, like SAE, there are different classes. Title 13 calls them tables. For omnidirectional beacons, the proper table is Table 2. Some manufacturers will claim that their LED beacon meets Table 4, but that table is for strobe, gas discharge lights, not LED, and Table 4 is a much easier table to meet. Table 2 requires a 12,500 candela intensity and Table 4 requires only 125 candela. Find out about the difference between lux, lumen, and candela. Yes, a 100x difference. Like SAE, most claims to Title 13 compliance don't specify the table number, which, as you can see, can make a huge difference. Another specification you should pay attention to is CISPR 25 for RFI. CISPR 25 is a specification for radio frequency interference. While RFI used to be a huge problem with strobe beacons, it is less of a problem with LEDs but is still prevalent. Like SAE CISPR 25 has standards within it. Class 1 is the most permissive, and Class 5 is the toughest class and is basically zero RFI. RCMP in Canada has the toughest specification in North America for RFI for their emergency lights, and they specify Class 3 or better. Class 1 is very easy to meet, Class 2 is better, and Class 3 is tougher. We recommend you look for RFI specifications of Class 3, Class 4, or Class 5. Note that some vendors don't even test for RFI, but it can cause interference with two-way radios and other electronics. Since beacon lights are generally mounted on the vehicle roof near the radio antennas, RFI specifications are important.